So let's take a look at some like number 12, part I in particular. And what we're doing is we're writing this sum in summation notation. So the first thing to do is to see what your index goes to. We're told to start with I equal 1. So this first fraction is when I is 1. And then we go to I equal 2, I equal 3, I equal 4, I equal 5. So that's going to tell me right away I'm going to start with I equal 1 and go up to 5. What's the expression though? Well, if you look at the numerator, 3, 6, 9, 12, 15, those are multiples of 3, right? This is 3 times 1, where I is 1 here, so 3 times I. 6 times 2, right? I is 2. Sorry, 6 times 2. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12, and so on. So they're multiples of 3. So in this case, it's going to be 3i. The bottom is, notice 7, 8, 9, 10, 11. They're consecutive integers. But notice in each case, because of that, they are exactly, if I is 1, notice 7 is exactly 6 more, right, than 1. If I add 6 to 1, I get 7. And then 2, 6 plus 2 is going to be 8. 6 plus 3 is going to be 9. 6 plus 4 is going to be 10, and so on. So, right, they're increasing by a fixed amount. That means that the index is also increasing by that same fixed amount. So I can simply add 6 to each index to get the denominator. So the bottom is 6 more than I. And so here's my expression. And the thing about the once you have it, you can check that you're right by just plugging in. Let's plug in. Well, I is 1. What do I get? 3 times 1 is 3. 1 plus 6 is 7. I get 3/7. That's the first fraction. When I is 2, do I get 6/8? Yes, I should, right? And you can check that out and verify it. So you'll know you have the right summation formula by just working back to reproduce your original sum. A little bit more real quick on 12e. This is the one actually that's given in 12e. And if you look at this, it goes from I equal 1 to I equal 6 if you count off. But these are what? 2, 4, 6, 8, 10, 12. These are even numbers or multiples of 2. So just like above, we had multiples of 3. Multiples of 2 is going to be 2i. And so the summation I equal 1 to 6 of 2i. And you can, again, get these values back. What about 3 plus 5 plus 7 plus 9 plus 11 plus 13? Well, notice those are odd numbers, starting with 3, of course, and ending with 13. And you count them, you got 1, 2, 3, 4, 5, 6. So it's I equal 1 to 6. And how do you express these? Well, notice that odd numbers are just one more than an even number. In fact, if you look at the previous one, right, 3 is 1 more than 2. 5 is 1 more than 4. 7 is 1 more than 6, and so on. So I can take the expression for even numbers, 2i, and add 1 to them, 2i plus 1. And that will give me the corresponding odd numbers. One last one, I want to just look at this one here. Now this one looks very similar to the one in 12e. It starts 2 and then 4, but then all of a sudden it changes to 8 instead of 6, and then 16 instead of 8, and so on. Notice I begins at 2 is I equals 1, and then there's ending at I equal 5. So we're going from 1 to 5. But what are these? These are not multiples of 2. These are powers of 2, right? This, in fact, is, we can think of 2 to the first power. This is 2 squared. This is 2 cubed, right? 2 times 2 times 2. This is 2 to the fourth, and this is 2 to the fifth. These are powers of 2. And so I equal 1 to 5. 2 to the I would be the way to write that summation notation. So a lot of this is pattern recognition. Not too much of this will be required in what we're using right now. We will go a little bit later in the end of the semester and talk about sequences and series, where this sort of pattern recognition and being able to write, sort of general terms for the summation is going to be helpful for us. So a little bit of exposure to it now. So try the rest of these problems in number 12, and hopefully this will be of benefit to you.